This is film number 5 in this series of films on the TCP IP protocol stack. And in this film we will concentrate on the IP address itself and also something called the subnet mask. And if we look at the configuration of a PC, you can do that by typing ipconfig. I will show that later. You will see two things. First of all, the PC has an IP address, and the IP address is unique to that PC. If you use public or global addressing, it will be unique worldwide. If you use private addressing, it's unique within your network. But still, it's unique. And the host always has a subnet mask as well, shown here as 255.255.255.0, and it also has something called a default gateway. So this is all in the setup of this PC. IP address, subnet mask, and default gateway. The subnet mask, if we translate that into binary, it shows the boundary between the routing prefix and the host number or host ID. So if we take a look at this particular PC, let's see what we have here. I have typed the command ipconfig, and this is what showed up. I have an IP version 4 address, which is 158.3.7.84.71, and a subnet mask 255.255.252 and 0, and then the default gateway. So let's study the different numbers here. If I convert this to binary, that would be 4 sets of 8 bits each. So you have 8 bits representing 158, 8 bits representing 37, and so on. All in all, 32 bits, as the IP address is 32 bits. This also, the subnet mask also converts to 4 groups of 8 bits, making 32 bits subnet mask. Now let's study the different numbers here. If I start my calculator, which is in the computer, and I select programming, so I go programming here. If I type a number, for example 255, I type 255 there, you see that it shows up as binary, simply 8 ones. So the first section here in my address is 8 ones. The second section is also 8 ones. So let's study 252. 252, you have 6 ones followed by zeros. So there you have 6 ones followed by zeros, and finally the number 0 is converted to 0. So this is finally 8 zeros in binary. Now all in all, I have 8 plus 8 plus 6 ones. So that means I have 22 ones followed by 10 zeros. And the division line between the ones and the zeros is where we have the division line between the routing prefix and the host number. So that is what specifies the division line between the two. Alright, what do we use this for? Well, if I send a message from one computer to another, if the target computer is within the same subnet, I will send, or my computer will send the message directly. And it is within the same subnet if we have equal addresses where the subnet masks have ones. If they are different where the subnet mask has ones, well, then it's not in my subnet. Therefore, the message has to go through the router. In Windows, it's called the default gateway, but it's really a router. So it goes to my nearest router, and here is the address to my nearest router. So let's study a few examples here. I have this example where the sender's IP address is 192.168.001.148. Usually you don't write those extra zeros, but I've done it in this case. This translates to 192, these first 8 bits. I can check it using my calculator, which is over here. So 192, 2 ones followed by 6 zeros. Alright. 168 translates to this. 1 translates to this. And finally 148 translates to this. The target 192.168.001.10557, and of course you see 192 same sender and receiver, 168 1 same, but they are different here in the last section. So the target address same, 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 and then different. Now my subnet mask, the sender's subnet mask, in this case 255.255.255.0, which translates to here 255 only once, 255 another set of ones, 255 a third set of ones, 0, 8 zeros. Now the source and the target, they have to be equal where the subnet mask has ones, and they are. We can check bit by bit that they are the same. They may differ in the area where the subnet mask has zeros, and they do. For example, here different, here different, and here. So they are different here. But since the source and the target has the same address in the portion where the subnet mask has ones, the computer here knows, the sender knows that the message can be sent directly to the receiver. Instead, if it wasn't the same, it would have to send the message to the router instead. And in my setup, there is an address to the default gateway, which is the router, which will be used if the two don't match. So let's turn over to example 2. I have changed the sender is 192.168.1, and I have 3 here, 148.57. The two addresses convert to in binary, and you see that they are different here. This is 001, and the lower one here is 003. They are different in the portion where we have ones in the subnet mask, since this is the subnet mask, and therefore the message will have to go to the router. So my computer compares my own address, the receiver's address, compare it up against the subnet mask, and decides whether to send it directly or send it to the subnet, to the default gateway, which is the router. A third example, 192.168.001.148, 192.168.001.057. So they are the same, the 3 first groups of 8. The 3 first groups of 8, they are the same. The subnet mask, 255.255.255, meaning only once. Then in the last one here, you have 128. 128 translates to 1 followed by 7 zeros. You can check that by using the calculator again. So I clear it and type 128. Sorry, again, 128. A 1 followed by 7 zeros. So they have to be the same to the left of this division line here, because this is where you have ones and this is where the zeros start. A subnet mask will never have a mix of zeros and ones, so you can't have 100011001100. It will always be ones followed by zeros. And therefore, since the sender and receiver, they are not the same on the left to the left of this division line, the message will have to go to the router.